Hello, my name is Greg Simonian, and I'm a graduate student at the Ohio State University Department of Astronomy. I'm going to talk about a paper I co-authored with Paul Martini entitled Circumstellar Dust, PAHs, and Stellar Populations in Early-type Galaxies, Insights from GALEX and WISE, which can be accessed at the link below. Early-type galaxies are those which do not show obvious signs of spiral structure or dust lanes, as late-type galaxies such as our Milky Way do. They are often characterized as red and dead because of the old stellar population which dominates their light, and their greatly reduced levels of new star formation. Embedded within the stellar population are asymptotic giant branch, or AGB, stars, which produce circumstellar dust grains in their atmospheres and shed them into the surrounding interstellar medium. The grains are usually destroyed quickly because the stars are embedded in a 10 to the 6 Kelvin plasma, which erodes them away. However, about half of early-type galaxies do show signs of diffuse dust in their interstellar media, and whether this dust is internally produced or externally accreted is still under debate. It's also been found that the polycyclic aromatic hydrocarbons, or PAH dust grains, emit differently in many early-type galaxies than in late-type galaxies. The typical late-type galaxy has PAH emission at 6.2, 7.7, 8.6, 11.3, 12.6, and 17 microns, while most early-type galaxies have significantly reduced emission at shorter wavelengths. We performed aperture photometry on WISE and GALEX images on galaxies from the ATLAS 3D and Rampazzo samples. ATLAS 3D is a volume-limited survey of 260 intensely observed and modeled early-type galaxies. This extensive ancillary data makes it very attractive for our study. We also used the 91 early-type galaxies with Spitzer IRS spectra uniformly analyzed by Rampazzo et al., who classified their sample into 5 distinct classes based on those infrared spectra. In order to best use our sample, we divided it into galaxies with and without diffuse dust by using either the Rampazzo classes or the ATLAS 3D dust lane and CO detections. We compare our galaxies without diffuse dust to the stellar population synthesis models, particularly the Flexible Stellar Population Synthesis, or FSPS code, of Conroy, Gunn, and White. One of our results are that a model with a single IMF, short for initial mass function, is inadequate at describing our sample. A range of IMFs are needed. This is in agreement with the results of Conroy and Van Dockum, as well as the ATLAS 3D team, which were done with optical spectra. We also find that the circumstellar dust model in FSPS is inconsistent with the stellar population of age given by the ATLAS 3D fits to SSP models of optical line indices. This inconsistency can be due to lower mass AGB stars being dustier than predicted, systematics in the measurement of stellar population ages from optical line indices, or a ubiquitous intermediate age stellar population in early-type galaxies which is not detected in the optical. Regardless of the source, this means that much work will have to be done before circumstellar dust can be considered a reliable age tracer of stellar populations. We also find that the mid-IR based star formation rates are unreliable for galaxies with very low specific star formation rate, less than about 2 × 10 to the negative 12 inverse years. Lastly, we turn to the sample of galaxies with diffuse dust. One factor that can affect the line ratios of PAHs is the ionization state of the grains. The ionization state should be determined by the temperature, electron density, and ionizing radiation field. We look at the dependence of the anomaly with the hardness of the ionizing radiation field and find that there isn't a correlation between them. We also don't see a trend in electron number density or temperature. Therefore, the physical conditions in early-type galaxies don't seem to imply a major change in the ionization distribution. We also check the size distribution against other environments, such as Seyferts, which also exhibit anomalous PAH emission, and liners. We don't find a deficit of small grains in early-type galaxies, despite the hot plasma, or in any other environments containing PAHs. We also do not find an overabundance of large grains in early-type galaxies with respect to star-forming galaxies. However, we find that Seyferts have larger grains than both, which may be tied to an overall metallicity effect. Therefore, we do not find any obvious differences between the environments of anomalous and normal PAHs. Some hints that we do have are that both early-type galaxies and Seyferts, the anomaly trends with the presence of shocks. However, these shocks do not seem to be tied immediately to AGN activity. For more information on these topics, please see our paper on the archive. Thanks.